Hi guys, let's talk about how to draw proper Lewis structures. So when I took Orgo 1 about a year ago, these were the 4 steps that kind of helped me to draw Lewis structures the right way. And after this I'm going to do, a bunch of examples, so hopefully you'll kind of get it. So first thing you want to do is add up the total valence electrons. Then you want to add or subtract electrons according to the charge of the formula. The second thing you want to do is draw a single bond from the central atom to each surrounding atom. To figure out what's your central atom, you kind of have to do a lot of practice, and most of the time common sense will kind of tell you which is your central atom. And the most important step to me is filling the octet rule of the surrounding atoms first, then the central atom, by adding lone pairs. So you do the octet rule of the surrounding atoms, then you do the octet rule for the central atom. And last but not least, you want to double check the number of total valence electrons in your overall Lewis structure. And this must equal the number you calculated in step 1. Let's go ahead and take a look at the periodic table. This actually helps you to figure out what your valence electrons are. I don't know if you can see the number with the letter 1A, 2A, 3A, 4, 5, 6, and so on. So these are all transition elements. You can ignore those, and your valence electrons are usually the group numbers. So this is 1, 2, 3, 4, and so on. So for example, the halogens, which are known as group 7, fluorine, chlorine, bromine, iodine, these have valence electrons of 7, oxygen have valence electrons of 6, nitrogen 5, carbon 4, boron 3. So yeah, get yourself used to the periodic table of elements. As soon as you practice that, it'll get a lot easier for you. This is something from my notebook. This chart really helped me to learn some of the common bonding patterns that you should know in organic chemistry in both 1 and 2. So what you really want to focus on is the valence electrons of common atoms, and then the neutral structure. For example, oxygen has 2 bonds, nitrogen usually forms 3 bonds, carbon forms 4, and notice that boron does not form an octet but is still a neutral atom when it has 3 bonds, because boron's valence electron is only 3. And then chlorine, 1 bond. So these all have octet with the exception of boron and some other elements. And another thing you want to pay attention to is what does a positively charged atom look like versus a negatively charged atom. Okay guys, in our first example we have ammonium chloride. And I'm going to first add the total valence electron. I get 5 from nitrogen, 4 from hydrogen, and 7 from chlorine, which gives me a total valence electron of 16. And then I'm going to go ahead and draw in my central atom, which is nitrogen, bonded to 4 hydrogen, which I get by looking at the formula. And usually by practice you'll figure that out. So I get 4 hydrogens bonded to my central nitrogen. And notice that I'm drawing the chlorine to the side, because here I'm going to put a big star next to my note that says the chlorine atom is drawn as a chloride atom instead of a covalent bond with the nitrogen like here. You cannot draw a covalent bond because chlorine in any solution of ammonium chloride, it carries a charge and it's like floating in the solution. So we usually draw that to the side. Other ions that we draw to the side is like sodium, other halogens, okay? And next I'm going to go ahead and check how many of the total valence electrons have we used from the 16. So I have used 1, 2, 3, 4, 5, 6, 7, 8. I have used 8 out of the 16, and I'm left with 8 more electrons, which I'm going to give to chlorine to give it a full octet. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to check the charges. Notice that a neutral chlorine atom would form 1 bond. And since it's missing a bond, we're going to give it a net charge of -1. Okay? And notice that a neutral nitrogen atom would form 3 bonds. Since since it has an additional bond, we're going to give it a positive charge. Okay? And you want to double check, do we have 16 total electrons? Yes, we do. We have 8 here and then 8 here. And do we have the right formal charges? Yes, we do. We have the nitrogen with the positive, chlorine with the negative. Another way you can calculate the formal charges is by using the formal charge formula. Okay, let's go ahead and do more examples. So here's example 2. Here I see is carbon bonded to 3 hydrogen, bonded to oxygen, bonded to 2 hydrogen. And notice that the overall formula, which is in brackets, carries a positive charge. So let's go ahead and do our total valence electron, which is step 1. I get the 4 from the carbon, 3 valence from 3 hydrogens, 6 from the oxygen, 2 from 2 hydrogens, right here. So my total adds up to 15 electrons. Notice that there's a positive net charge. To get a positive charge, I must subtract an electron, minus 1, which gives me 14 total valence electron. Why did I do the subtract 1? Because electrons usually carry a negative charge, right? So if you're saying that the overall formula has a positive charge, you have to subtract an electron to get that positive charge. So our total valence is 14, and I'm going to go ahead and start drawing. I see that there's a carbon bonded to 3 hydrogen. I'm going to go ahead and draw that because that's what the formula tells me. And then I see that it's bonded to an oxygen that's bonded to another hydrogen, bonded to another hydrogen. The oxygen is bonded to 2 hydrogen, right? And this oxygen is bonded to the carbon, which is bonded to 3 hydrogen. Now, how did I know how to draw this? Is because carbon, if you look down here, carbon usually forms 4 bonds. That's usually. Sometimes, it's not the case. Hydrogen always, and only always forms 1 bond. So I know that hydrogens can only form 1 bond. And I know that oxygen usually forms 2 bonds. Here is the wrong way to draw it, okay? I'm going to draw the wrong way so you see why I'm exaggerating that. The wrong way, this is wrong, okay? Is to go ahead and put the CH3 and to say that I'm going to have another H bonded to an oxygen bonded to an H. You cannot say that because here you see this hydrogen is bonding 2 bonds. That is wrong. Hydrogen only forms 1 bond. Let's go back to here. Let's count how many valences we have, and we have to check that do our electrons add up. So we have, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We only have 12 out of the 14. So 14 minus 12 is 2. We must add 2 more electrons. And to complete the octet, hydrogen already has a full octet because, as usual, hydrogen can only form 1 bond. The carbon has a full octet because it has 8 electrons. This hydrogen is full octet, full octet. Now, the only one that's missing an octet is the oxygen. So the remainder 2 electrons goes to the oxygen. And let's count up again. Do we have 14 electrons? 2, 4, 6, 8, 10, 12, 13, 14. Yes, we do. And that right here is the correct answer. Let's do one more example. Okay, so our next example is sodium methoxide. Let's do our total valence electron. I get 1 from sodium, 6 from oxygen, 4 from carbon, and 3 from 3 hydrogen, which gives me a total valence electron of 14. And here's the wrong way of doing it. If I say that, I'm going to go ahead and put a big star next to my note, which says, note that sodium forms ionic bonds, because it has a huge electronegativity difference from the oxygen. So you cannot draw sodium covalently bonded to oxygen because sodium forms ionic bonds, which means that you would have to draw sodium separately. So here's the right way of doing it. I'm going to draw the sodium to the side. Then I see that there's the oxygen bonded to a carbon, and the formula has 3 hydrogen attached to it. Now I'm going to check to see if I have the total valence electron of 14. I'm going to count, and I'm going to do the surrounding atoms first, and then I'm going to do central atom. Surrounding atom, let's see. 14 minus 8, I have 6 electrons left. I'm going to go ahead and add them, because I see that oxygen only has 2 electrons. 1, 2. That's not a complete octet. To get an octet, you must have 8 electrons. So I'm going to go ahead and add 1, 2, 3, 4, 5, 6. And now oxygen has a full octet, hydrogen has an octet, hydrogen has an octet, hydrogen is good. Hydrogen is, is the exception to octet rule, so this is good. And carbon, the central atom, doesn't have an octet. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yes, all atoms have a full octet. Notice one last thing we're missing is the charges. Even though the complete formula does not show you the charges, we know that oxygen, a neutral oxygen, would have 2 bonds. Here, our oxygen only has 1 bond. It's missing a bond, so it must carry a net charge of -1. And a sodium neutral atom has 1 bond. Since it's missing a bond, this sodium must be a positive charge. Okay, so that is your answer. Let's do